Hello everyone, my name is Ray, who is in charge of the technical service. Today, I'm going to introduce you the modbus essentials. This is the first lesson to learn IEG products. First of all, I will tell you the history of modbus quickly and explain what is modbus. The modbus is a layer 7 application layer protocol and the communication mechanism between modbus devices is one request and one response. The last part I will explain how modbus works. Let's start today's course. Modbus is developed by Modicon, now Schneider Electric, in 1979 to exchange information between products on the factory floor. It has become a de facto standard communication protocol because of simple and robust. There are three main reasons for the use of modbus in the industrial environment. The first one is openly published and royalty-free. The second is easy to deploy and maintain. The third is moves raw bits or words without placing many restrictions on vendors. And the modbus organization is an association formed of independent users and suppliers of modbus compliant devices that seeks to drive the adoption of the modbus communication protocol suite and its evolution to address architectures for distributed automation systems across multiple market segments. Before learning this course, you may not hear about modbus before. Then you may have a question. Where can you find the modbus? In fact, modbus is just around us. For example, the dancing water at Bellagio Hotel in Las Vegas, and the air conditioning system of Den Haag Central in Netherlands, and the meters along the pipeline in Alaska. Okay, let's back to what modbus is. Modbus is an application layer messaging protocol positioned at the level 7 of the OSI model. That provides client-server or master-slave communication between devices connected on different types of buses or networks. In today's course, we will introduce you the modbus RTU ASCII, which based on RS-232, 422, and 485, and the modbus TCP, based on the Ethernet technology. Here are two nouns I would like to introduce before going to the following slides. The first one is PDU, the Protocol Data Unit, which is defined by the Layer 7 protocol modbus. And when a PDU is passed down to the lower layers, it may be added the additional address or error check because of the different technology or different layer. And with the address and error check, it's called Application Data Unit, the ADU. And for the following slides, before the second section, how modbus works, we only talking about PDU. And since the second section, we will discuss about the ADU. Modbus is a one port in, one response protocol. And you may be curious about what is one port in, one response. Imagine that you are a security guard of a building and you want to know if the emergency door at the 7th floor is open or closed. But you are at the 1st floor now. What will you do? Take the elevator to 7th floor and check it? No, that's the old way. Today, we just pick up the HMI, similar to iPad with touch panel, and choose the emergency door at 7th floor icon, and the HMI, the modbus master, will generate a polling and send it through the network to the PLC, which can detect the status of the emergency door. At that moment, the PLC generates the response: the door is open or the door is closed, and then reply it back to your HMI. When you receive it, you will know the status and you can decide what to do next. The PLC will not alert you automatically when the emergency door is opened from closed. It will only respond a polling from the modbus master. And this is one polling, one response. When a modbus request is received by a modbus slave device, how it responds it, and how it reads from or write to its internal memory. The modbus slave will check the function code first. The function code will tell it how to read or write to its internal memory by the primary tables, and which I will introduce you later. And the next step is to find where it should start to read or write. After that, it will generate the response, and if the request is read, the response will include the data from memory. And if it's write, the response will report how much data has been written to the device. This slide shows the function code list, and the most popular function codes are highlighted. From 01 to 04 are read function codes, and the function code 05, 06, 15, and 16 are the write function codes. Now, let's explain the primary tables. It defines the memory type of a block of memory. If it's read-only, or you can read or write it. And how you read or write, by bit or by a word. For example, the function code 03, which means read holding registers. It will read the memory by a word each time. And this is an example from the user manual of a modbus device. It tells user how to read or write data with this device. The second part is how modbus works. And after this slide, we are talking about the application data unit. Based on different physical media, modbus has different variations. In this course, we will focus on modbus RTU ASCII and the modbus TCP. This is a comparison sheet of those variations. The major difference between modbus RTU and the modbus ASCII is the data format. Modbus RTU is using hex code and the modbus ASCII uses ASCII code. And the key feature for modbus TCP is it supports multiple masters. With modbus RTU or ASCII only supports one master. And from the next slide, let's start with the modbus RTU and ASCII message frame. The above sheet is the modbus RTU message frame, and below is modbus ASCII. The ADU of modbus RTU or ASCII message frame has 6 fields: the start, slave address, function call, data, check, and end. For modbus RTU, it uses idle time to define the start and end. For ASCII, it uses specified characters, current as start, and CRI feed as end. Since there may be multiple slaves, the slave address is used for specify a target slave ID to respond this request. And the function code tells the slave what to do, to read or to write. And the data tells the slave where it should start read data or write to the internal memory. And the CRC check or LRC check is for checking if the request command is anything wrong about the data. Here is an example of normal request and the response. For a request, the modbus master asks slave ID 01 to respond this command. And what should be respond? Let's check the function code. 03 means read holding registers. And for the data field, this read command should be started from address 00 to 1 unit of holding registers, which means 2 bytes of data. And let's see what has been responded. First, it shows the response is from slave ID 01 by the slave address. And function call shows this response is replied to a command function call is 03, read holding registers. And then how about the data? Length 02 means the data is 2 bytes long and the value is flowing as 0001. And request for 1 word data and the response for 2 bytes of data. It's a little tricky, but this is how it works. Here is an example for abnormal response. The request is the same, but here comes an error at modbus slave. So it replies an abnormal response to tell the modbus master, here is an exception. To show it, the modbus slave will change the highest bit of the function code from 0 to 1. For this example, means the function code is changed from 03 to A3 in the response message. And it will put exception code in the data field. The exception code 02 means illegal data address, which means this slave device may not support to read holding registers from the internal memory address 00. And if you are interested in exception code, I attach the detailed list in the appendix. Since this slide, let's discuss about the modbus TCP message. The modbus TCP frame add a MBAP header before the modbus PDU. The MBAP header means Modbus Application Protocol Header. A header is 7 bytes long and separate to 4 parts. The first one is the transaction identifier. It is used for transaction pairing. The Modbus server, or you call it slave, copies it in the response from the transaction identifier of the request. The second part is protocol identifier. It is used for intra-system multiplexing, and the Modbus protocol is identified by the value 0. The third part is length. The length field is a byte count of the following fields, including the unit identifier and the data fields. The last part is the unit identifier. This field is used for intra-system routing purpose, and the details I'll explain it later. And the Modbus TCP message are sent via TCP on a registered port 502. This slide shows an example for the request and response of Modbus TCP communication. You can reference to the page of Modbus RTU communication. The PTU parts are the same. Let's focus on the MBAP header. The transaction ID is a random number to identify the pair of request and the response. And the protocol ID 00 means Modbus protocol. The length field shows the bytes of the following fields, includes the unit ID, function call, and the data. And the unit ID means if this request is passed to other physical medium, which slave ID should respond this request. This slide shows an abnormal response similar to the one on Modbus RTU I have explained. After learning Modbus RTU ASCII and Modbus TCP, do you find a problem? The message frame of Modbus RTU ASCII and Modbus TCP is totally different. How could they communicate to each other? When you have this requirement, you will need a Modbus gateway. A Modbus gateway can translate Modbus TCP packets to Modbus RTU ASCII packets and pass it to the correct Modbus device. So the Modbus master can send a request to a Modbus slave, which runs a different variation of modbus through a modbus gateway. How does a modbus gateway do it? Remember the force field of the MBAP header? The unit identifier. This field is used for intra-system routing purpose, and it is typically used to communicate to a modbus or a modbus plus serial line slave through a gateway between an Ethernet TCP/IP network and a modbus serial line. This field is set by the modbus master in the request and must be returned with the same value in the response by the slave. That means the modbus gateway can, based on the unit ID, to tell which modbus slave on the serial line should respond the request. Then it could complete the request-response transaction pair. Let's recap the modbus solutions. The first and the second one are the original usage. A modbus RTU master communicates to a modbus RTU slave, and a modbus TCP master to a modbus TCP slave. With the gateway, the third one is a modbus RTU master communicates to a modbus TCP slave, and the fourth is a modbus TCP master connects to a modbus RTU slave. After today's course, you should remember that the modbus is an application layer protocol, and it uses one request and one response mechanism to communicate between master and slave. And the last thing is the modbus gateway can help to communicate between modbus RTU, ASCII, and TCP devices. Thank you for your time, and congratulations to you to finish this course. Remember to take the quiz of this lesson to check how much you have learned.